This is lesson 25-2 on inscribed angles. Um, we are on the Springboard version of the textbook, just so I can use the online version of the protractor. Mr. Moonion placed this, the link to this Google Chrome extension. He placed the link on the website. So if you haven't put it on your Google Chrome extension yet, you should be able to find it there. You don't have to if you want to just do this with pencil and paper and old-fashioned protractor. You'll just need to print this off so that you can get the right size angle. Although you can do the activity even if you don't have the same exact size angle. That's not important. So yeah, you could just draw yourself a circle and stick an angle in it and everything else would work out just fine. So I'm going to start the protractor. This should start out over here. They should both start out at 0. And then I'm going to move it so that the center of the protractor is on the vertex of, or is on the center of that circle. It's really hard. It's very touchy. And the arrows don't work. But anyway, I think I've got it there. I might be just a smidge off. I'm going to move the blue over here to B. And I'm going to move the green one over here to A. And I know, there it is. I know what the answer is supposed to be, so I adjusted it a little bit. It's 40. If you put 41, it's not going to matter. Like I said, the measure of the angle is not that important. Okay, now this is where trouble keeps happening. So I am going to attempt to turn on my drawing tool because the next thing, I'm sorry, I was also going to show you that it says use a protractor to find the measure of angle AOB, which is what we just did. The measure of angle AOB is 40, and the measure of arc AB is 40. Why? Because angle AOB is what kind of angle? It's a central angle. Why is it a central angle? Because its vertex is at the origin, or the vertex is at the center of a circle. If the vertex is at the center of the circle, then it is a central angle. Just think center, central. They go together. And if I turn my answers on, you'll see that we're right, 40 and 40. Okay, now I'm going to attempt to turn my drawing tool on because it says choose any point on the major arc and label it P. And then, so I'm going to come over here to the circle, somewhere over here, not the green shaded part, but over here on the major arc, I'm going to put a point P, and then I'm going to connect A to P and B to P. Okay, so that's what it asked me to do. So here we go. Okay, I think my drawing tool is on. So I'm going to put a dot. It doesn't like my pen, but I think it will let my mouse do it. Isn't that dumb? It doesn't like my pen. Okay, now I'm going to draw a line. And my line's going to go from, I forgot to label it P, but I will in just a second, from there to there, and from there to there. Okay, I'm going to go back now to P. Well, I'm just going to use my mouse. It likes my mouse better. Okay, so there's point P. So we've done the drawing like it said. Now I'm going to turn the drawing off. So, well, because I can't even scroll. So I'm going to turn the drawing off so I can scroll. And the drawing went away. Yeah, this is just not working out for me. Choose any, okay, we did that. Name the arc intercepted by angle APB. Well, if you remember what it was the exact same arc as this one right here. So I think what I can do is copy and paste this real quick. And go, oh, I know, I can just go here. I can draw on this one, no problem. Okay, so we got that 40, because really all we needed was to measure that the first time. We put P, I think it was somewhere right here. And we can call that P, and we draw that. I just don't have the nice straight lines. But it says, name the intercepted arc. Okay, so here's the point P. It goes down to A, and it goes down to B, and the piece of the circle that is between the two chords that make up angle APB is the exact same piece of the circle that make up, or that's between the two radii that make up central angle AOB. They have the same arc. It says draw, so when we did this, it says that this right here is called an inscribed angle. Now this is important. Inscribed angles, you got to know them. You got to know them. Now, central, because its vertex is at the center. Inscribed, because its vertex is on. Now, later on, we are going to find angles that intersect inside the circle, and lots of students mess up with inside, with inscribed. So just be sure you remember, inscribed is on the circle. Inscribed, the vertex is on the circle. Now, we know that the measure of this arc right here is 40 degrees. But when we go and measure this, and you're going to have to take my word for it, because I am not going back to that online thing and trying to measure the angle with a protractor and draw and all that kind of stuff. It's not working. So you're going to have to take my word for it. When we measure this angle, it's not 40 degrees. It is exactly half. It is 20 degrees. Now, it would be much better, so if you want to get pencil and paper and protractor out to prove it, that would be lovely. List the characteristics of the inscribed angle. We said vertex, sorry. Vertex is on the circle. The sides of the angle are chords. Okay, we found the angle. I promise you it's 20 degrees. And draw a different point R on the circle, then draw a new inscribed angle that has a vertex R that intercepts AB. And so they said, okay, come over here and pick another point. And now make this inscribed angle intercept that arc. Well, guess what? It's going to be 20 degrees too. That's because any angle that intercepts that arc right there, okay? Any inscribed angle that intercepts that arc is going to have a measure of 20 degrees. And the reason is that the formula for make a conjecture about the measure of the inscribed angle. So the measure of inscribed angle is equal to half the intercepted arc. So the measure of the inscribed angle is equal to half the intercepted arc. Test your conjecture by measuring 3 more inscribed angles. You're welcome to do that. So the measure of the intercepted arc was 40. I don't even know what item 7 is yet. This was 20. This was 20. Oh, central angle, sorry, was 40. Central angle was 40. Inscribed angle was 20. Inscribed angle was 20. 7 says, based on any patterns that you see in the table above, write a conjecture about the relationship between the measure of an inscribed angle, and the measure of the central angle that intercepts the same arc. I don't know how I'm supposed to answer that and that. This table's not making any sense. I'm skipping it. I'm tired. It's been a long day. You'll get the point here in just a minute. I promise. HIA. Now, one thing that I will tell you that will help a lot when you have a picture like this that's really busy. If you want to work with angle HIA, it is so helpful. Okay, well, that doesn't match exactly. It is so helpful to redraw the picture just using the parts that they're asking you about. So let me draw the circle again. And I'm going to do A. Looks like it's at about the center of the circle. It comes down and then it goes up. Okay, so there's HIA. It's so much easier to see now that that's gone. Okay, it does tell me the measure of angle HCA is 40 degrees. Is 50 degrees. So I'm going to go ahead and mark that as 50, and I'm going to mark arc HA as 50 because this is a central angle. So if arc HA is 50, then this HA, which is the same one, is 50. Now, I is an inscribed angle. Why? Its vertex is on the circle. So the angle is half the arc. Angle equals half the arc. This is inscribed. Okay. Central, the angle is equal to the arc. Okay, so for central, the angle is equal to the arc. For inscribed, the angle is equal to half the arc. Or 2 times the angle is equal to the arc. However you want to do it. Either one of those is the same. So if I know the arc right here is 50, then this one right here is 25. The measure of angle HCR. HCR. That's a central angle. And if this is 50, this is 130. Because that's going to make a diameter. See, AR is a diameter, so I know from here to here is 180. So from here to here is 130. So the measure of angle HCR is 130. The measure of angle HIR. Okay, again, HIR. Now, we just found, remember, that HR is 130. That arc is 130. So the piece of the circle, that's the intercepted arc, for this inscribed angle, the arc is equal to half the angle. So if you take the arc, multiply it times a half, you'll get the angle measure. So HIR is half of 130. And I believe, if my arithmetic is correct, that's 65. Now they want the measure of angle AIR. Well, that's going to require a new picture. A, and then R, and then I is over here. Okay, what do you know about A and R? They are the endpoints of a diameter. Okay, so that means that this is a semicircle. Okay, so the measure of angle AIR, the arc, the intercepted arc of that inscribed angle, the angle is going to be half of the arc. So the arc is 180, so this is going to be 90. Because half of 180 is 90. Write a conjecture about inscribed angles on the diameter of a circle. They are right angles. They are right angles. Why? Because half of 180 is 90 every time. Don't need to do the proof. I'll go through number 11. Actually, I'm not. I'm going to go ahead and stop because I don't know if this is necessary. So I'm going to look over it and see if it's necessary. If it's not necessary, we're going to skip it if it doesn't teach you anything new. And I don't think it does because all we had to learn was inscribed angle measures, and that's just half the arc. So if that's not going to teach you anything new, then when I come back, I will just be going over the check your understanding. Okay, so start the next video before you start the homework, and then I'll tell you on the next video.